Okay, let's look at finding limits from a graph. So here we've got this function, this f of x, and we want to talk about the limit, first of all, as x goes to -1 from the left, this part right here. Okay, so how do we approach that? Well, I come up here to -1. See, it says approaching -1, and I just stand there. And I say, okay, I'm wanting to talk about approaching -1 from the left. So I go straight up until I hit graph to my left. In other words, I go up until I get to a point where I could just branch off on that graph and move to the left. And I take note of my altitude up there. See, how high am I up? Well, I'm up at 2. So that left-hand limit would be 2. Now, if we talk about, well, what about approaching from the right? The limit as x goes to -1 from the right. Well, here I am at the graph, and I go up until I find that there is graph to my right, and I take note of how high up I am. Well, I'm at 2 for this one as well. So the left-hand limit and the right-hand limit are both 2. And if those are the same, then that means my overall limit is 2. So I have a left-hand limit and I have a right-hand limit. Now, let's come over here. It says the limit as x goes to -4. Yeah, -4 right here. Okay, as x goes to -4. Now, notice that at -4, they don't ask what the left-hand limit and right-hand limit are. They just say, well, what is the limit as x goes to -4? Okay, that's what this one is. Well, I just come up here to -4, and I notice that there is a difference here. There's a jump. Now, when I see that jump, in other words, if I approach from the left and if I approach from the right, I get to 2 different heights. In fact, the left-hand limit, like that, of this function, is going to be 3. Okay. However, the right-hand limit, the limit as I approach from the right, okay, of this function, the same function, the right-hand limit, that's going to be something different, right? So I'm here and I move up until I have graph to my right. And I take note of the altitude up there, and that looks like it's going to be 4. So the left-hand limit and the right-hand limit are different. So this one does not exist. The limit as x goes to -4 does not exist. Now I could talk about the limit as x goes to 4. It's the same story here. You notice there's a jump. So right away we could say the limit does not exist. And we could say, okay, the limit as x goes to 4 from the right, let's see what that height is. Well, I'm right here at 4. And I want to move down until I have graph to my right here. And I take note of the altitude, and that one is, looks like -2. See that? Then I could say, well, what about if I come from the right? I mean from the left, from the negative direction. Well, I come down here, here's graph to my right, keep moving down till I have, oh, there it is, and I take note of the altitude. So that would be -3. Yeah. So the fact that those are different means that the left-hand limit and the right-hand limit, well, because the left-hand limit and right-hand limit are different, that means that the limit overall does not exist. Okay, so let's look at another one here. So here's one. And you notice, okay, so you train yourself so you can say, oh, I can see right away where the limit's not going to exist. The limit's not going to exist here at -5, and it's not going to exist over here at 5. So right away when they ask, let's see here, here we could say does not exist. And at 5 does not exist, no problem. We can immediately determine those limits don't exist. However, the limit as x goes to 1, well, the left-hand limit, the right-hand limit, those are the same. They're both 3. See, this is 3 and this is 3. So the limit overall is 3. See, There's no jump or anything. So these are a couple of examples so that you can see, well, how you can evaluate limits just by looking at a graph.